So welcome back. We have started how to find the rank of this matrix. So in our last class we are discussing about this question. To find the rank we have to take that equals to A equal to 1 2 3 1 4 2 2 6 5, and we have to mention this symbol, and our main target, this is your diagonal elements. So below the diagonal elements must be equal to 0 so that we can reach our upper triangular matrix. This is our main focus. Clear? So that's why first element is 1 and 2. Both the element 1 2 6, these three elements must be converted to 0. So first is 1 means that will belongs to first column, means that will be converted to 0 by using first row only. Okay, so this belongs to R2, this belongs to R1, means you are you want to convert R2, means first element equal to 0, so you will write R2 change that equal to R2 minus R1, because both are same. So if you will subtract both element, that means that equals to 0, means R2 change R2 minus R1, so that your R1 as usual you have to write, and R2 now you are changing. So 1 minus 1 0, then 4 minus 2, that is 2, 2 minus 3, that is minus 1. Then come to next one, the another value is 2 for this matrix, another 2 is also you want to convert that equals to 0. So by the help of R1, so this 2 belongs to R3, so you write R3 change. Okay, so here the value is 2, but here the value is 1, so you have to multiply 2 in the first row so that both the elements will be equal. Then after subtracting, your value will become 0. Okay, so that's why you are writing R3 minus 2 R1. So that equals to 0, means 2 minus 2, that equals to 0, 6 minus 4, that equals to 2, 5 minus 6, that equals to minus 1. Next point, but now you are getting these two elements are 0. Next come to this value, this 2 must be equal to 0, and that will be converted to 0 by the help of R2 only, because this element lies on this diagonal. That means this the R3, the 2 value must be converted to 0 by the help of R2 only. So it will be written as R3 change, means this 2 belongs to R3, means R3 change, and both are same value, means R3 minus R2. So as usual, R1 R2 we have to write as usual. So 1 2 3 0 2 minus 1. Okay, then 0 minus 0, 2 minus 2, minus 1 minus 1. So that equals to 0. So our main target, these three elements must be 0, and we are reaching, and we can obtain our upper triangular matrix. Now you can say this is a triangle form. 1 2 3 2 minus 1 0. So this is a triangle, means this triangle can be created in the upper side of this matrix. So that's why this is known as upper triangular matrix. So your focus, you have to convert your question into upper triangular matrix. Clear? So now you have to count to find the rank, you have to count the non-zero row. Non-zero row means in a row there are 3 rows are there. So in a row, if non-zero values are present, that row is known as non-zero row. Okay, in the third row you can see all the values are 0, means this is known as 0 row. Okay, so rank is the number of non-zero row. So in first row the non-zero values are present, so it will be counted as 1. Then second row non-zero values are present, so it will be counted as another row, means there are 2 non-zero row. This is not a non-zero row, so hence rank of A equal to 2. Clear? Then come to another example. Find the rank of the matrix 3 minus 1 2 minus 6 2 4 minus 3 1 2. Let us start. Suppose we are denoting that is A equal to this much, and this is the equivalent symbol. Okay, so in our previous question we are using the another symbol, so here we are using this symbol. Both are same meaning. Okay, so here the diagonal elements are 3 2 2. This is a diagonal element. So your main target is to convert the element below the diagonal. The element lies below the diagonal, means minus 6 minus 3 1, they lies below the diagonal. So your main target is to convert these 3 elements equal to 0. Okay, so one by one you have to convert. So first of all you think about minus 6. So minus 6 belongs to R2, that's why you are writing R2 change. Okay, so minus is minus 6 will be converted by the help of R1. So here 3 is there, so minus 6 is not present. That means you have to multiply 2 here. So you write R2 plus 2R1. Why it is plus? Because both are having opposite sign. Opposite sign means if you will add, then they can cancel. Okay, so that means that value becomes 0. So that's why R2 plus 2R1. So R1 here I am writing 3 minus 1 2, and R2 minus 6 plus 6, that means 0. 2 minus 2, we are multiplying 2 in R1, so 2 minus 2, that is also 0. 4 plus 2 into 2, that is 4, so 4 plus 4 is 8. Clear all of you? So this is your one element you are converting to 0. Then come to, this is your minus 3 also. Next focus about the minus 3, and that belongs to R3. That's why we are writing R3 change, and minus 3 that must be converted to 0 by the help of R1 only. So in R1 the first element is 3, here is first element is minus 3. So if we will add both the element, then that equals to 0. So we are writing R3 plus R1. Okay, so 3 minus 1 2, 0 0 8 0 0 4, then it is equivalent to, also we are getting 3 elements are 0, but in this case we can see R2 and R3 both are having same value in the same position, means this both the row can be converted into single row. So you see R3 change to R3 minus R2, that means you can becomes like this, 0 3 minus 1 2, 0 0 8 0 0 0. Okay, that means we are multiplying 2 in the third row, so it will becomes 8, then 8 minus 8 equals to 0. You can't do this one. Okay, so that equals to, here the non-zero rows are 1 and 3, 1 and 2. Okay, so rank of A equal to 2. Complete. Then come to, so we have completed our about the rank of the matrix. Then come to about the consistency of linear system of equation. This is very important for you, consistency of linear system of equation. Okay, this is your last part. The system of m linear equation with n unknown, x1 x2 x3 da 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 up to xn, are in the form of like this. Okay, so first of all you have to know about the linear equation. What is about the linear equation? You know, all of you, 2x plus 3y equals to 4. That is known as linear equation because power of xy is 1. Okay, so that's why those equations are known as linear. But x square plus 5s plus 6 equal to 0, that is known as quadratic because highest power of x is 2. Clear? So similarly, so you know about linear equation and quadratic equation are there. Okay, but here we have to take the linear equation and system of linear equation. System of linear equation means more than 2 linear equations are there. Okay, the total system is known as system of linear equation. So we have to take many more linear equations are there. Okay, so here you can see here a11 x1 plus a12 x2 plus a13 x3 dotted up to a1n xn equal to b1. So any equation can be written like this. Okay, so means they are the variables here. Suppose n number of variables are there. Okay, and the values which are written in adjacent to those variables, those are known as coefficient. a11, a12, a13, those are known as coefficient, and right hand side are denoted as b1, b2 dotted up to bn. Clear? So there are m number of rows, and n number of variables are there, means those are known as unknown. Okay, so how can we convert this? Where coefficient matrix A equal to, here you have to write two matrices. One is coefficient matrix, another is augmented matrix. Clear? One is coefficient matrix and another is augmented matrix. Clear? So A equal to means you have to collect coefficient, means those are the coefficient of your unknown, means a11 is a coefficient of x1, a12 is a coefficient x2, means you have to collect only the coefficient, means a11, a12, a13, a1n, a21, a22, a23, a2n. Similarly you have to collect and mention in your coefficient matrix. So you can see a11, a12 dotted up to a1n. So all these are represented here. This matrix is known as coefficient matrix. Similarly, augmented matrix, that will be denoted as K, that equals to. It will be, this is a matrix of two parts. One part, in the left part you have to write your A again. In your right part you have to write your right hand side value of your equation. Right hand side value of equation means these are the B1, B2 up to Bn. So those will be written in this right part. Okay, and this line is known as pipeline. Clear? So now the total matrix is known as augmented matrix. In augmented matrix, it has two parts. In one part means divided by pipeline. In the left part, A will be written, means coefficient matrix will be written as usual, and in the right part, your right hand side value of your equation will be written. Clear? So if the system of linear equation, you see, if the system of linear equation has a solution, it is called as consistent system. Otherwise, the system is called inconsistent. You know, whenever in your 10th level you have solving 2 to 3 linear equations and you have the value of x, y, z. Okay, if you are finding the value of x, y, z, then you say those equations are consistent. If you are unable to find the value of x, y, z, then you say your system is inconsistent. Likewise, here is also same thing. If it has a solution, you say the system is consistent. If it has no solution, you say the system is called inconsistent. Clear, all of you? That means you have to remember about two words. One is consistent, another is inconsistent. Consistent whenever solution is there, inconsistent whenever solution is not there. Clear? Then after one scientist, they gave a theorem. Scientist name is Roches Theorem. What he said? The system of linear equation is consistent if and only if the coefficient matrix A and the augmented matrix K are of the same rank. Otherwise, the system is inconsistent. You know how to find the rank, okay? And if you find the rank of A and K, if both have same rank, then the system of equation, the system of linear equation is known as consistent. If both have different rank, then the system is known as inconsistent. Okay, so this Roches theorem, this is your Roches theorem. Sometimes in your exam, the statement will happen, write Roches theorem or state Roches theorem. So you have to know Roches theorem is the system of linear equation is consistent if and only if rank of A and rank of A are equal. Okay, if both are unequal, then the system is inconsistent. Clear? Then, so this is a Roches theorem. Then come to working procedure. The long question will be there to test the consistency and find the solution. Sometimes your long question will happen, test the consistency, means test whether there is solution or not. If there is solution, then find the solution. Clear? So this is known as consistency, means is there any solution or not. Okay, so you have to follow this procedure. Step 1, express the given system of equation in matrix form. You have to express in matrix form because your question will give you equation only. You have to convert in matrix form. Step 2, you have to write coefficient matrix and augmented matrix. Clear? As we have explained here, this is your coefficient matrix, this is your augmented matrix. Clear? Similarly, convert the matrix A and K to a triangular matrix or upper triangular matrix using elementary transformation method. Already we have completed in rank. To find the rank, we are using the row operation. Okay, means the elements lies below the diagonal, they must be 0, and to convert 0 you are using so many row operations are there. Okay, so this thing, step 3 means you have to find the rank of A and K. Okay, then step 4, determine rank of A and rank of K. You have to find the rank of A and the rank of K. Okay, then step 5, there are two cases are there. One is rank of A equal to rank of K, otherwise rank of A is not equal to rank of K. Sometimes may happen. Suppose your rank of A equal to 3, rank of K equal to 3. Okay, so you write case 1. If your rank of A equal to 2, rank of K equal to 3, that means you write case 2. Okay, so you have to remember. So rank of A equal to rank of K, that means that equal to number of variable. Number of variable always in your question x, y, z must be there. So number of variable, then given system of equation is consistent, means both are equal as according to Roches theorem, that is consistent, and both are equal to number of variable means having unique solution. Clear? Otherwise, if rank of A equal to rank of K less than number of variable, the system having infinite many solution. Case 2, if rank of A is not equal to rank of K, the given system of equation is inconsistent, that is have no solution. Then last step, if the system is consistent, convert the reduced matrix form to equation form and solve the equation to find the solution. Okay, so we can clear in our example. Okay, So this is your example. Test the consistency and solve. So 2x minus 3y plus 7z equal to 5, 3x plus y minus 3z equal to 13, 2x plus 19y minus 47z equal to 32. So we'll clear in our next class, okay, this example.